We want to use the t-table to find bounds on the p-value for a situation where we were doing a right-tailed test. This would be for the population mean, with the test statistic found to be 2.52 and our sample size is n equal to 5. If you click on the link to the t-table, it should take you to the table. When we have a n equal to 5, that means that our degrees of freedom would be 4 because we use n minus 1. So we're going to want to go to the t-table and look in row 4 for 2.52 and just find where it lies in that list of numbers because it's not going to be there exactly. So looking in row 4 of our t-table for 2.52, what we find is that it is between these two values of 2.132 and 2.776. So let's jot down that information. Now, what we want to look at is what tail areas correspond to those numbers in the table. 2.132, if we look at the top, it has a tail probability of 0.05, and the 2.776 has a tail probability of 0.025. So these have tail areas of 0.025 and 0.05. What that means then is, since we're just doing a right-tailed test, we don't have to multiply by 2, means that our p-value would be bounded between these numbers. The smaller number is 0.025, so our p-value is greater than 0.025 but less than the larger, which is 0.05. The idea here of what we're doing to get our p-value is we can't find it exactly, but we can bound it from the information in the table. For a right-tailed test with 2.52, what the p-value looks like in picture form is this shaded area right here. That's what we want to find. What we can do when we go into our table is find some different numbers that we actually have in our table. And when we looked in our table, we were able to find the numbers of 2.132, which is smaller, so over here. And we knew that that had a tail area of 0.05. So this region is 0.05. And we also got the other bound to be at the number of 2.776, which had an area of 0.025. And so what we see is the region that we're looking for is between these two, so its area is between those two, giving us a p-value between 0.025 and 0.05.